Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Step-by-step solutions for each part. A. SN2 reaction rate concept. SN2 reactions proceed via backside attack by the nucleophile on the carbon bearing the leaving group. The rate is highly sensitive to steric hindrance. A primary alkyl halide, less hindered, reacts faster than a secondary alkyl halide, more hindered. CH3Br is a primary, methyl, halide with no steric bulk around the carbon, while CH3CH, CH3, isopropyl bromide, is secondary with two methyl groups creating steric hindrance. Therefore, CH3Br undergoes SN2 more rapidly. Why the other fails? Isopropyl bromide has two flanking methyl groups that block backside attack, significantly slowing SN2. B. SN1 reaction rate concept. SN1 reactions proceed via carbocation intermediate formation. More substituted carbocations are more stable, hyperconjugation, inductive donation. A secondary carbocation from isopropyl bromide is more stable than a primary methyl carbocation from CH3Br. Therefore, isopropyl bromide, CH3CH, Br, CH3, undergoes SN1 more rapidly. Why the other fails? CH3Br would form a methyl carbocation, which is extremely unstable and essentially does not form under normal SN1 conditions. C. E2 reaction to give Z1,2-diphenylpropane concept. E2 requires antiperiplanar geometry between H and the leaving group, Br. The product, Z1,2-diphenylpropane has pH and H on the same side, CIS, at C1 and pH and CH3 on C2. Working backward using the Brett stereochemical analysis, in the Fischer projection with pH, top, HBr, C1, H CH3, C2, pH, bottom, the anti-relationship between H and Br requires them to be antiperiplanar. In a Fischer projection, groups on the same side are SYN, eclipsed conformation, and groups on opposite sides are anti. For E2 elimination to give the Z alkene, the correct stereoisomer is the one where H at C2 and Br at C1 are anti in the relevant conformation. Analysis of the first Fischer projection, pH top, H on left at C1 with Br on right, H on left at C2 with CH3 on right, pH bottom the H, C2 left, and Br, C1 right, are on opposite sides of the Fischer projection, meaning they are anti in the extended chain conformation, satisfying E2 antiperiplanar requirement and giving the Z product. The second Fischer projection gives a different stereochemical relationship leading to the E product. Therefore, the first Fischer projection is correct. D. Reaction with NEE to give Z1,2-diphenylpropane concept. NEE in acetone affects an SN2 reaction, Finkelstein type, replacing one Br with I, generating a vinyl bromide or an iodo compound that then undergoes elimination. More specifically, NEE acts as a nucleophile in SN2 to give an iodide, which then undergoes E2-like elimination. The dibromide that reacts with NEE, one equivalent, to give Z1,2-diphenylpropane must have the correct stereochemistry for anti-elimination. For the first Fischer projection, pH top, HBr at C1 Br, CH3 at C2 pH bottom SN2 at C2 by I inverts configuration at C2 then E2 anti-elimination of HBr gives Z alkene. This stereochemical pathway is consistent with the first dibromide giving the Z product. The second dibromide, both Br on same side in Fischer, would give the E product after the same sequence. Therefore, the first Fischer projection, pH top HBr Br CH3 pH bottom, is correct. E. SN1 reaction rate for naphthalene derivatives concept. SN1 rate depends on carbocation stability. The left structure has Br at C1 of a dihydronaphthalene where C1 is allylic to an endocyclic double bond but also part of a vinyl allylic system. However, the carbon-bearing Br is sp2-like or has limited stabilization. The right structure has Br at C1 of 1, 2, 3, 4 tetrahydronaphthalene tetraline where C1 is a benzylic sp3 carbon adjacent to the aromatic ring. A benzylic carbocation is highly stabilized by resonance with the aromatic ring. The left structure's carbocation at a vinyl allylic position adjacent to a non-fully aromatic system is less stable than a fully benzylic carbocation. Therefore, 1 bromo 1, 2, 3, 4 tetrahydronaphthalene, right structure Br on benzylic sp3 carbon undergoes SN1 more rapidly. Why the other fails? The left structure's C1 bearing Br is at a vinylic or allylic position in a system that does not generate as stable a carbocation as a pure benzylic position adjacent to a fully aromatic benzene ring. Therefore, the correct answer is A. CH3 Br, B. CH3 to CHBr, isopropyl bromide, C. Fischer projection, pH, top, HBr HCH3 pH, bottom, D. Fischer projection, pH, top, HBr CH3 pH, bottom, E. 1 bromo 1, 2, 3, 4 tetrahydronaphthalene, Br on the benzylic sp3 ring carbon. Therefore, the correct matching is A matches CH3 Br, B matches CH3 to CHBr, isopropyl bromide, C matches Fischer projection, pH, top, HBr HCH3 pH, bottom, D matches Fischer projection, pH, top, HBr CH3 pH, bottom, E matches 1 bromo 1, 2, 3, 4 tetrahydronaphthalene, Br on the benzylic sp3 ring carbon.